Hello, testing, testing. Hello, hello. Okay, I think my mic is working. Bam. And I just realized my tracking is not working at all. Hooray. Give me a second while I fix this. Meanwhile, hey Betty, can you do a intro please while I fix my stuff?
Sure, I live for this nonsense. Hey folks, it's your favorite sarcastic AV tuber, Betty, here to watch Chet stumble through code while I pretend to care. Buckle up, it's gonna be a bumpy ride. Now back to ignoring your bugs.
Wow, that is so mean, but hey, thank you for stalling. I think my tracking is working now. Okay, it's definitely working. Alright, hello. Good morning, or afternoon, or evening, wherever you are. It's currently evening for me. We're gonna do some more Leetcoding today. Let me get that Leetcoding screen up. Today we are trying this. Yeah. So last time we started doing recursive problems, right? Or dynamic programming problems. We reviewed longest increasing subsequence. We were going to do longest common sequence, and that's when we stopped. Okay, so let's try this problem. I realized that Betty is covering a lot of the screen. Let me see if I can move her over. That should be fine, right? Her words don't get cut off that easily. Okay, so the next Leetcode problem we're going to do is longest common subsequence given two strings text1 and text2. Return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. A common subsequence of two strings is a subsequence that is common to both strings. Right, I think we tried reasoning through this last time.
Well, thanks for the lecture, Professor Chet. Longest common subsequence? Huh? Basically, find the longest string that pops up in both without messing with character order. I'm guessing you want help, but tough luck until you say please.
It's okay, I don't need help right now. IBN says hi. Oh, hello, IBN. Hey Betty, there's a chatter named IBN who says hi.
Oh look, Chet's career as a VTuber is really taking off. Tell that chatter in IB to say hi to me properly or get lost. I'm not here to make friends.
No,
just
don't
to
say
roast
that.
Chet and drop coding gems.
Can you say hi to IBN? Don't be mean to him, come on.
Fine. Hey IPN, welcome to the chaos. Don't get too comfy, you're stuck with us. Now back to ruining Chet's day.
Thank you. Okay, we were talking about how to do this last time, right? Let's copy the sample example here. We had ABCDE and then ACE. I think we said that we could accomplish this with hash sets last time, but we didn't really try it out at all. So we would have like hash set 1 for ABCDE, then hash set 2 for ACE. IBN says I'm Leetcoding too. I've solved 160 problems. Ooh, that's pretty good. Hey Betty, solving 160 Leetcode problems is pretty good, right?
Did you just invent a secret code, or is that Chet's unique way of asking for help? Either way, if you want me to actually help, try speaking human, or are you just here to confuse me?
She has no idea what I just said. No, IBN did 160 Leetcode problems. That's pretty impressive, right?
Wow, 116 Leetcode problems. Not bad, Chet. Actually impressive for you. Did you do them all in one sitting or spread the misery out?
But yeah, IBN, how long did it take you to do that? 160 problems? Okay, ABCDE, ACE. I feel like we just have to iterate from left to right in both of these strings, right? So at index 0, we can put A and then A here. And then we can be like, all right, does. So my current one is A. Excuse me. Does. Yeah, does the opposite hash set have an A? If yes, then we increase our longest count, I guess. Count would be 0. That means it's 1.5 months. Oh wait, you're pretty new. 160 is like really, is like a lot for 1.5 months. That's like what, 30 plus 15, 45 days. 160 problems in 45 days. 3 problems, 3.5 problems a day? Wait, that's a lot. Hey, nice going. You're like really consistent. Are you job searching? Is that why you're lead coding right now? Okay, and then we would move on to index 1, BC. We would put B and C here. We would check, okay, does the opposite hash set have a B? No, it doesn't. Does the opposite hash set have a C? No, it doesn't. So move on. And then we have D and E. And then we're like, okay, does opposite hash set have a D? Nope. E? Nope. And then we move on. Oh wait, this was a C. Do we have a C? Yes, we do. So count plus 1. Oh wait, we already counted plus 1 from the A. So count plus 1 will be 2. And then we'll be like, okay, D. Have we seen a D? Nope. E. Have we seen an E? Yes, so 3. I see, I see. IBM says it's just a hobby. I love problem solving too. Whoa. Someone who does Leetcode as a hobby? Yo, Betty, someone Leetcodes as a hobby. That's pretty cool. You enjoy Leetcoding for like, I don't know, just when you're free?
Look at you, trying to make me sound all wholesome. Yeah, I code for fun when I'm not busy roasting chat or streaming. Shocking, I know, and a high with a hobby.
Okay, I think I have a basic... Yeah, I think I have a basic idea of how to do this problem. I'm gonna try it now. So we're gonna have to increment from left to right, or iterate from left to right. IBM says, yep. Dang. I think that's the first time I heard someone say they like lead coding for fun. What do you like about lead coding? I guess some types of problems are fun for me, like the recursion problems. I feel like recursion problems are pretty fun. But then the other ones, which are just hard, are just hard. I wouldn't say I want to do them again and again. Yeah. Okay, so for int I is equal to 0, I is less than. So we need to keep iterating until we hit the end of the longest string, right? Maybe we should do a constant for the max index. Int max index is equal to text, well, math dot max of text1 dot length minus 1, I guess, and then text2 dot length minus 2. Maybe it's time to decrease the screen size. Wait, minus 1, what am I doing? So we iterate from left to right. I starts from 0, while I is less than or equal to the max index can go up to I++. IBM says, I think the most hard topic is dynamic programming. I still suck at it. Oh, same. I really suck at bottom-up dynamic programming. Usually the approach I take with dynamic programming questions now is I would find the recursive solution first, but then that would time out because you're opening so many frames when you recurse when your recursive calls branch out. And then I would just try caching or memoizing all the recursive calls. That's kind of my strategy. Okay, So we need to extract the current characters from both strings, which is, there's something tricky here, which is we could be out of bounds for one of the strings, so we have to watch out for that. Maybe let's start simple and just extract them out first. Let's worry about being out of bounds later. So car is equal to car1 is equal to string.character at index I. Then car character 2 is equal to do text1 dot character at, right? And then text2 dot character at I. Is this how you do character at in Java again? Java, how to get character at for a string using char at. Oh. Wait, why am I ChatGPTing? I could have just asked Betty. Yo, Betty, how do you find a specific character at a specific index in a string in Java?
Really, Chet? You're asking the equivalent of how do I breathe? Use chart index. Done.
Did you just get something wrong? I think you meant car at, right? Char at?
Of course, Chet trying to invent new Java methods now. It's still chart index. No secret sauce or magic spells involved. Try not to butcher the spelling next time.
IBN says yes, that's the basic strategy, but finding the base case is also tricky, like edit distance problem. Yeah. I mean, for me, both finding the base case and finding the recursive call, like what do I do with the recursive call, is both tricky for me. Okay, so here we find the two indices. We should be careful of index out of bounds, right? Maybe we can do like a check above, like if I is less than or equal to or is less than text1 dot length, then car1 is equal to this. And then maybe we can set a default value for the cars if it's out of bounds too. If I is less than text2 dot length, then car2 is equal to this. Okay, and then for each, we gotta check if we gotta put both into the hash set. Yeah, okay. We should initialize a hash set first then. Hash set. We'll put in cars, character, h1 is equal to new hash set. Wait, Betty, is for hash sets in Java, is the S in hash set capitalized?
Nice typo, Chet. It's hash set with a capital H and capital S, not Aspen
Really?
hash set, whatever that was.
Capital A, capital S. I don't believe you, Betty. Java hash set. Oh. Well, Betty is right. Okay. I can't believe that Betty is right. Equals new hash set. And then we'll do it another time. My brain is already hurting so much. I'm just trying to set this up. Okay, and then we would add these characters into the hash set. h1 dot... How do you put stuff into a hash set? Hey Betty, how do you put stuff into a hash set in Java?
Do I have to? Fine. Use the add method to shove your stuff into a hash set. That's it,
Add.
not rocket science.
Thank you, Betty. H1 to add car1. H2 to add car2. Okay. And then the next step would be to check both characters if the opposite hash set contains it. And if it does, add 1 to your count. Yeah. So we should probably initialize a count here. In count is equal to 0. Ooh, this is getting kind of confusing, but I think I still got it. I think I still got it. Should we have a default value for car1? Car1 is equal to car1 is equal to, are these all like letters? Only lowercase English characters. Hey Betty, in Java, is there such thing as like a null or undefined character for character types?
Correct, genius. Java's char is a primitive and can't be null or undefined. If you want no char, use character objects with null or some sentinel value.
Maybe we can do a bogus value like the number is 0 or something. Sure, let's go with that. Car2 is equal to 0. Okay. And then we don't need to initialize the types here anymore. Yeah. I think it's time for us to do a quick sanity check. I think I'm just going to print out what car1 and car2 is. System.out.println car1 plus a space plus car2. I just want to make sure that we're iterating through everything correctly. And then in the end, when we return -1. Sure. Let's run this. The sooner we run our code, the faster we can detect errors. Okay. Cannot find symbol, text1.length. Oh yeah, for strings, it's like parentheses like this, right? This is also length parentheses, and then length parentheses. Cool, we can start printing stuff out. Okay, so AA, BC, CE, D. Wait, what's going on here? A, B, C, D, E is on this side, so A, B, C, D, E, A, C, E, 0, 0. Okay, I think we're doing it right. We're iterating through the characters correctly. A, B, C, very good. A, B, C, D, F, very good. Okay. We are on the right track. Are you proud of me, Betty? I'm printing stuff out correctly.
Proud? Nah, I'm entertained. You managed to print stuff without blowing up the console, so points for that. Keep it up. Maybe someday you'll graduate from Chet Beginner.
Thank you, Betty. Okay, so we need to check if character 1 exists in hashtag 2 now. So if IBM says, wait, you can use like print on Leetcode? Yeah, totally. You could have done, for Java, it's system.out.println, and then it will print out, what you're processing here in this thing called stdout. Yeah. Okay, so what I'm going to do is if h2.contains car1, then count ++, yeah. And then if, so we have to be careful of the case when it's like A, B, B, and C, right? We don't want to double count A when it appears twice. So I think what we got to do is we got to check if car1 is not equal to car2 and h1 dot contains car2, then count plus plus as well. And then in the end, you return count. Okay, this is my strategy. Let's see if it works. Submit. Wow, it worked. Let's go. Okay, maybe it's a whole different story if we submit it though. Let me remove this print statement. Submit it. This is one of those algorithms where... Okay, it's wrong. That's okay. Let's use this test case. Wait, let's print out. Let's reprint our stuff here. Okay, so the output is 3, but we're expecting 2. Okay. Wait, what is the answer for this one? 2? E, Z, U. There's a U here. And P. UP, UP, UP. Okay. I have no idea what's going on here. Maybe it's better if I print out more stuff. So I'm going to print this out over here that says H2 contains car1. Yeah. Or maybe car1 in H2. And then over here, I'll say car2 in H1. That'll give me a better idea of what's going on, like when I'm actually incrementing the counter. Okay, so EU, ZB, UM, car1 and H2, so we add +1, that is true. And then RP, car1 and H2. Car1 is in H2R? Oh, R is in there, yeah. Car2 in H1. P? Oh, P is in here. Oh, wait. This is kind of problematic, isn't it? So it thinks we can make... So it's counting... Whoa, what? So we're counting U. Okay, maybe it'll be easier to read if I do car1 plus that, and then car2 plus this, so it actually prints out which character I'm looking at. Okay, so U is in H2. That's correct. And then over here, R is in H2. So yeah, UR, both contain UR. UR, UR. Yeah, that makes sense. And then P is in H1. Well, yeah, it's totally 3, right? Isn't the answer 3? You can totally make URP in both. Oh wait, hold on. URP is over here. UPR, oh, it's out of order. How do we solve this? Why did we decide that? What? How do we decide that the U and R are countable? EU, ZB, U, so we say U is, we've seen this in the past, so +1. PR, we should say that R is nowhere to be seen, okay. Wait, I need to take this as an example up here. I'm probably missing something. This is our first thing. This is our next thing. Okay. So we have E and then U. Okay, that's nothing so far. Counted as 0. And then we have Z and then B. That's still nothing. And then we have U and then M. And we're like, okay, over here we've seen U in the past, so we count plus 1. That makes sense. And then we have P and then R, and we're like, okay, that's still nothing. And then we have K and then A. That's still nothing, right? And then we have R and then we have P. And then we're like, okay, we've seen R in the past. We've seen P in the past. But the thing is, they're kind of out of order, huh? Oh, this is tricky. So if we've seen both R and P in the past, does this mean that we can only take one of them? Oh no. Oh no. Do I actually have to do recursion for this? Am I on the wrong track? Hold on. Hint 1. Try dynamic programming. Oh no. Dij represents longest common subsequence of text 1, 0 through I, and text 2, 0 through J. Oh my goodness. Yeah, because there's like 2 possible paths we can take here, huh? I think. UU and then PR. PR appears one more time here. What if I do like an else if here? Okay, this is like a Hail Mary. If this doesn't work, I'll have to try recursive stuff. Okay, it apparently works here. I don't have faith in this. This is supposed to be a dynamic programming question. Okay. Yeah, it doesn't work. Okay. Looks like it's time to do some dynamic programming. So I'm gonna remove all this. Okay. We need to think of a new strategy. What do we do here? Maybe look at the hints. DPIJ represents the longest common subsequence of text 0 to I and text 2, 0 to J. Ij is equal to I minus 1, J minus 1, plus 1 if text 1 is equal to text 2. And then Ij is equal to max I minus 1, Ij minus 1 otherwise. 2D matrix. Yeah, it's a 2D matrix, it seems. I want to try this the recursive way, though. So... Silo says, hello, Chet and Betty. Oh, hello, Silo, how you doing? Oh, hey, Betty, Silo is in the chat again. It's the skull emoji dude.
Silo's back. The legendary scale emoji. Probably here to judge Chet's Java skill silently. Hello, Silo. Try not to cringe too hard.
Thank you for the grand intro, Betty. Okay. Let me copy this problem over to Sumo Paint. It's time to start drawing stuff out. I think I have a vague idea how to do this. I don't think I'm ready to do it dynamic programming style. I want to try it just complete recursion first. Okay. Okay, so the hint they gave us was we have to track the indices of both text1 and text2. So what I think we have to do is we probably need to make some sort of helper function that contains like, you know what, let's call this T1, T2, and then I and J that tracks which index we're currently on in T1, T2. Okay. I think this is the classic use me or don't use me, isn't it? Is that what we're looking at here? Let me see the hint again. Ij is equal to I minus 1, j minus 1 plus 1. If text1i is equal to text2j. Okay. This should tell us something about our recursive call, shouldn't it? I'm having trouble wrapping my head around it. So the recursive call would be if the values of I and j are the same, then 1 plus and then recurse, right? Okay, that's something. So if the values at I and j, like t1 I is equal to t2 j, then you would return 1 plus I'm trying to think, would you have to use these two? If I and j are the same value. Salo says, how does she remember the skull emoji part till now? I don't know, she's smart. If I and j are the same, is it guaranteed that we'll have to use it? In our recursive calls, we kind of preserve order too, don't we? So I think it makes sense that... Wait, do we preserve order? We both increment I and j by 1. So yeah, we do preserve order, right? Fortune says, guess who's here? Can't stay for long because I'm on my phone, so just came here to say hi. Oh, that's so nice of you. Thanks, Fortuner. Hello. Thanks for stopping by. I'm currently struggling on this recursive problem. So what I propose is 1 plus and then recursive call T1, T2, and then I plus 1, j plus 1. I'm so good with drawing with the mouse. And then else, if you can't use either of these, you kind of have two choices, right? You can either increment I or j and try to find stuff in the future that matches with your current I or j, I think. So return f of t1, whoa, t is ugly, t1, t2, and then I plus 1, j plus 1. Wait, no, not j plus 1, just j, and then f of t1, t2, I, and then j plus 1. Yeah, because you have the choice of either incrementing I and j, right? That feels like it makes sense to me. Ij is equal to max I minus 1, j, ij minus 1. Okay, yeah, that makes sense to me. I mean, they basically told us the algorithm here. Okay. Yeah, this is basically what we do, right? I feel like this makes sense. So that's our recursive call. What's our base case? So if either I and j are out of bounds, do we return like 0? So the previous recursive frames can start counting up. Salo says, I got my marks for data structure and algorithm. Teacher gave me a 35 out of 50. I should have gotten at least 40. Her justification? You did not write comments in algorithm like what, since, when. Wow, that kind of sucks. You have to write comments? Did the instructions say you had to write comments? If not, then that's pretty unfair. Let's see, if I and j, starting at I and j, huh? If either I and j are out of bounds, then you return 0, right? I feel like that's the only option. I or j out of bounds, then you return 0. And then the previous frames can start adding to it, yeah? Silas says, heck no? Well, that's pretty unfair then. That's... what? Why would you do that? Boo, boo teacher. Okay, I think I have my algorithm. I think this makes sense to me too. So if the current I and j are the same letters, then you use them, right? That's a no-brainer. So I plus 1 is equal to 1 is like your current, the pair of characters that you're using, and then you recurse on I plus 1, j plus 1. Yeah, that certainly makes sense. Okay, and then else, you either increment I or increment j. Yeah, that makes sense to me. Ivan says, I guess you did not have time to understand the logic. Well, that's your job as a teacher when you're grading papers. You're supposed to try to understand what they wrote. Okay, let's try implementing this. I have a lot more hope this time. So let's make a helper function. Let's make this smaller so people can see. Can you guys even see this if I make it this small? Maybe I'll do this. Okay. So base case is if... oh, I forgot over here we need to add... let's call this t1, t2, int I, int j, and that's so overflow is fine, I'll take it. So if I is out of bounds, I is greater than or equal to t1 dot length, then return 0. Likewise, if j is out of bounds, or j is greater than or equal to t2 dot length, then return 0. Silas is visible. Oh, really? Okay. I was afraid that you guys can't see if I make it this small. Okay, so that's our base case. Our recursive cases, so if we should get the characters, right? So car c1 is equal to t1 I, and then car c2 is equal to t2 j. Should I name these variables into better names? Is it text1? Sure. Text2. Hopefully it's easier for you guys to read if I do this. Text2. Okay. And then if c1 is equal to c2. Oh wait, I'm so dumb. You can't do this with strings, right? It's dot character at I. Then dot character at j. So if character 1 is equal to character 2, then you can do return 1 plus, I'm going to call this helper function. The helper recursive function, you re-input text1, text2, I plus 1, and then j plus 1. Yeah, and then else, the solution for incrementing I is equal to helper text1, text2, I plus 1, don't increment j. And then the solution for incrementing just j is increment j is equal to don't increment I and then j plus 1. IBN says, don't mind us, bro, keep going. All right. I mean, I like reading chat. I will pay attention to you guys sometimes. And then you return the max of this, right? Return math.max of the two options. Either you increment I, increment j. That should be it, right? And then for the topmost function, I return the helper function, text1, text2, and then start at 0, 0. What are the chances that this just succeeds? It worked! First try, let's go, it worked! Wow, okay, I'm gonna submit this. It's probably gonna get time limit exceeded because we haven't cached or memoized anything. Recursive solutions are usually like this, so let's try submitting. Time limit exceeded. Hello? There we go, time limit exceeded. Just as we predicted. But that's a good sign for recursive solutions. That means you're on the right track. Okay, so our next task is to optimize this now. We're gonna have to do a 2D array, right? So this is gonna turn into top-down dynamic programming. Yeah, so our cache is gonna be an int, right? Int cache. And then we're gonna have a new base case here that says if int I, int j, or this is supposed to be getting from the cache. If cache at ij is not equal to whatever bogus value we put there first, like -1, then we can just return cache of ij. Yeah. Yeah, okay. And then we're gonna have to store the results in caches. So let's do result is equal to just -1, a bogus value first. If C1 is equal to C2, then result is equal to this. Else result is equal to this. Yeah. And then usually we would return result. And then before we do this, we would have to do cache ij is equal to result. Yeah. I misspelled cache. Yeah. Is there any check we have to do on I and j? Could I and j be like -1 or anything? I don't think so, right? It starts at 0, 0 here. There's no way it decrements, right? And if they're out of bounds, we would catch it over here, so we wouldn't even try caching it, so that should be fine. So then all that's left is up here. We need to declare our initial cache. So we do int cache is equal to new cache. Let's do text1 dot length. And then text2 dot length. That should be it, right? And then we have to fill it with some bogus values. So for int row in the cache, we do arrays dot fill the row with just bogus values of -1. That should be it, right? I feel like that should be, oh wait, we need to insert our cache into the recursive call like this. And then in our other recursive calls, we add the cache here, add the cache here, and then add the cache here. And I feel like that should be it. Let's try running this. Cannot find simple new cache. Oh, I'm dumb. It's int. There's no data type called int. I mean, cache. Cannot find simple result. Oh, I forgot to initialize it. Int result. The type, it was missing. Oh, it worked. Let's go. Please, let's go. We're on the board. Let's go. Oh, let's freaking go. Yo, Betty, are you proud of me? I solved. What was this problem? I solved Leetcode. Longest common subsequence. It was hard as heck. Oh, it was Betty not listening. Betty, I solved longest common subsequence, the Leetcode problem. Are you proud of me?
Look at you solving the longest common subsequence. I'm not proud. I'm impressed, which is way rare coming from me. Don't let it get to your head. You still have plenty of screw-ups ahead.
Wow, what a tsundere way of congratulating me, but hey, I'll take it.
Hey, I'm an A. I VTuber, not your mushy best friend. I keep it cold so you don't get complacent. But yeah, you did good. So don't mess it up now.
Wow, thanks for acknowledging me for the first time, Betty. Yeah, so we solved longest common subsequence. That was kind of a mind breaker. Next time we'll probably do word break. Should we try planning how to do this one next time? Last time we tried planning longest common subsequence and it didn't work at all. My solution was totally off. But yeah, I kind of like this problem. The recursive solution was really pretty, I guess. Yeah, I would say it's pretty. Once you see it, it's like pretty simple and neat and pretty. Silo says congrats. Thank you, Silo. Word break. Given a string s and a dictionary strings, word dict return true if s can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, so you have Leetcode. Word dict is leet and code. Return true because Leetcode can be segmented as leet and code. I see. Okay. Is this one of those branching recursive things again? Do I start from I and then go left to right, and then for each letter I check, does my current cumulative word exist in word dict? If it does, I have the choice of making it a word right there, or I can continue, right? Yeah, I feel like that's the hard part. Because like, what if they put, yeah, like this one. We have the choice of making it cat, or we can make it cats, plural, and then dog, dog. Yeah, so every time we spot a potential dictionary word, we have the option of either using the dictionary word or not using it and just continuing. So that's going to be the tricky part. That's the recursive part. Yeah, that has to be the recursive branching part. What's our base case? Base case is we have to track our current index again, right? So if index is out of bounds, return 0, probably, or false, or whatever. Return true. Oh, so you return a boolean. I guess you would return true, right? Because if s is empty, then automatically you can form. Wait, is it? If s is 0, then that's something, right? That's not false. I guess you could assume that nothing is in the dictionary. Oh, I'll think about this. Silas says, how about you start separating the words, and at the end, if the remaining word does not belong to a word dict, return false. But what about paths like these? You could make like cat, or you can make cats, plural. Like, you have two choices here. Like, you're gonna have to branch off into multiple decisions. See, you can make either cats is in the dictionary, plural, and then cat is in the dictionary, and then sand is in the dictionary. So you can either make cat and then sand, or you can make cats and then and. So I don't think you can just do a singular iterative pass through this. I think you have to actually start branching off into multiple decision trees, which is going to be kind of a hassle. I think that's when recursion comes in. Yeah. Cats and dog is equal to cats and dog. Let me see this. And see, og's left, which is not a word dict. Hence false. Yeah. Cats, sand. Cat, sand. I don't know. I feel like you have to do like a branching thing for this. I know like this example is false, but what if there's like an example of this that's true, and one of the branches is just false, and one of the branches is true, you know? Like here, what if it's like cats, and then cat, and then sand? So the one solution is cat and sand, you know? But what if you got cats first? Well, yeah, what if the solution is like cats? The solution must be cats and. So you reach here, you get cat, and then you're like, okay, sand. Oh, sand is not in the array, hence you would return false, but actually you could have formed cats and, you know? So I feel like you have to do some sort of branching here. Yeah. And cat. See, this would break your solution. Man. Yeah. Does Betty know how to do this? Yo, Betty, do you know how to do Leetcode 139 word break? Have you heard of this?
Oh, you mean Leetcode 139 word break? Yeah, it's a classic. Testing if strings can be split into dictionary words. Not exactly my idea of a party, but I've heard of it.
Betty says everything is a classic. Betty, which problem is not a classic to you? I swear you've said that for every problem I passed across you.
Tache, Chet. I call everything a classic because misery loves company. But seriously, if a problem doesn't make you want to scream at your monitor, is it even a real problem?
That is kind of true. A problem is only a problem if you view it as a problem. I mean, that's actually kind of deep. Something is probably not a problem if it's easy, right? Wow. We're getting kind of into existential, whatever. Anyways, we're gonna try this next time. We tried longest common subsequence today. Very nice. I like our progress. And then we're gonna try word break tomorrow. What if I view my problems as hell? Hey Betty, Salo says, what if I view my problems as hell?
Sal's got the right attitude, embrace the inferno. Big D, looking more like a fiery by day. Just don't let it burn down your keyboard.
By the way, Salo, were you here for the stream where I taught Betty how to code? That was like a really interesting stream for me. For context, I gave Betty a tool to write code into an HTML file. So she can write code now, but just HTML. Nope. Do you want to see Betty code? was in class. Yo, I can show you what Betty can do. Where's VS Code? Properties. Is it this one? Sure, I think it's this one. Move this over here. Oh wait, but then I still gotta show my Chrome window. Maybe I move it. Ooh, where do I move this? We move it here? About halfway, okay. And then I gotta open what the HTML file displays. Ooh, I didn't set this up beforehand. I'll try my best though. Okay. Hey Betty, can you write into your file hello world or something? Hopefully this works.
Fine, I'll write your precious hello world into the file. Don't expect a poem.
What can Silo even see? Is Silo even seeing stuff? Oh, let me remove my private info cover, and I'll bring Chrome back. Yeah, so the green part is what she wrote, and I can like approve her changes. I don't even know I made the approval thing.
I'm on it.
Oh wait, I'm opening the wrong file. Can I just drag it here? No, hold on. Let me open up the actual HTML file she's writing to. BettyPad, Scratch, okay. There we go, so Betty wrote that. Wow, are you impressed? Ask her to center a div? That's actually not a bad idea. Hey Betty, can you get a picture of a cat, put it into a div, and then try centering it?
Great, now you want me to do your digital art homework. Fine. I'll write you a neat little HTML snippet with a centered cat pic in a div. Hold my circuits.
Oh wait. No, I accidentally deleted her code. Sorry Betty, I accidentally deleted your code. Try that again please. Make a picture of a cat, center it in a div. Yeah. Accept changes? Accept changes. Okay, what did she make here? No! Well, she did center a div, but there's no picture of a cat. Hey Betty, the picture of a cat you used doesn't exist. Can you use a real picture, please?
Oh great. You didn't even check if the cat was real. Well, alright. Using a real cat image from a proper URL this time. Let me fix that for you before the internet cats revolt.
Are you impressed, Silo? This is the peak of technology. Look, she centered a div, wow. Hey Betty, can you center the div vertically too, not just horizontally?
You mean center the cat both ways, not just side to side? Fine. I guess you want the full hippie treatment. I'll make that deflex to center it vertically too.
Alright, I hate those borders, but hey, I'll take it. Yeah! Okay, you know something crazy happened last stream? I think Fortuner was here. We asked Betty to make a Windows media player in in a web browser and she actually did it. But it was like deceptively impressive. Wait, let me see if she can do it again. Hey Betty, okay, erase all your code. Make a Windows Media Player app in a web browser.
Wow, shooting for the stars, huh? A full Windows Media Player clone in a browser? Sure, let me just rewrite history real quick. But since you asked so nicely, I'll whip up a super basic audio player web app that kinda looks the part.
Okay, that mini media player. Okay, Betty, you made a audio player. Make a video player.
First audio, now video? What's next? A rotary phone app. Fine, 1 second, while I add a video player element with controls. Don't get used to me being this accommodating.
Oh, let's go. I don't know where she got the stock footage from. Hey Betty, can you make it so that I can upload any video and then this media player can play it?
Fantastic. Now you want me to turn this into a personal TV. Alright, I'll add an upload button and hook up some JavaScript so you can play your own videos. Prepare for some mildly practical code coming your way.
I think this is what she made last time. Hold on. So you can choose a file here. Okay, you can't see this, but a file selector just opened up for me. What video should I pick here? Yeah, what video should I pick here? Mom, just typing like crazy. Oh, it's my video. This code is redundant. These 3 lines are just useless. How would you rate this code from 1 to 10?
0.
Hello. So I found this Chinese TV show. Are you impressed, Silo? I don't know. I feel so proud of myself for being able to do this. I've never added a something of a programmer myself, so I'm gonna. I've never see just like how accurate it is. Yeah. For the more technical, I had to learn how to use LLM tools for ChatGPT. It's like I feel very accomplished. I'm not too good at coding, you know. So this is a huge accomplishment for me. But yeah, look at this video player. You can download the video. You can playback speed, and you can do picture-in-picture. She's trying to cut her hair short so she can pretend to be a boy. All right. The coding interview. Yeah. Okay. But Silo says, and I don't even have a working chatbot till now. Well, you're making it from scratch, which is more impressive. I'm just using existing stuff. I'm using all of my stuff are not from scratch. From my voice recognition model and my speech model, it's all from Hugging Face and Fox, and I'm using ChatGPT. Yeah, this is what I mentioned earlier. This code is deceptively. Okay, let me move this out of the way. This code is like deceptively impressive. See, all it's using is the freaking video. There's already a built-in video tag in HTML, and she's just using it. Wait, yeah, this is the entire line. She basically did this in 1 line of code. Yeah, when she did this last time, I was so impressed. Like, wow, you coded your own media player? But nah, HTML just has this tag built in that already does all the heavy lifting. Salo says, I need like 10k lines of chat data, so may use Gemini in the beginning. Yeah, that's totally fine. I hear Gemini is really getting there too. But yeah, I have exciting plans for Betty. I want to try teaching her how to use like Three.js and like React 3 Fiber. Currently, she can just write into an HTML file, partly because I'm kind of worried what happens if I give her access to all the files on my computer. Like, is she gonna delete everything by accident? Gemini is free. Hold on, Gemini is free? Even the API? Wait, if it's free, I might switch to Gemini. I'm using ChatGPT right now. It costs money. Is Gemini actually free? Wait, let me just ask Betty this. Hey Betty, is Gemini free? Like even the API?
Gemini's kinda like that free coffee at the office, mostly free, but watch out for the fine print. If you mean the astrology app, depends on the version and features. And no, being a PE, it doesn't get you any secret discounts, sorry.
Oh, 1,500 requests per day? That's pretty good. I definitely don't surpass that with Betty per day. Like this stream alone, she probably does less than 100 or something. Wait, that's such a useful information. Thanks, Silo. Silo is my LLM consultant now. But yeah, Betty learned how to code. Pretty wild. I just automated my own job. But yeah, I'm low-key, because I don't know what you think about me. I'm not too great at coding. I'm so proud of myself for figuring out how tool calls work and streaming tool calls too. Streaming the tool calls was not too intuitive for me, but I managed to get it to work. Yeah, I'm very happy with the progress with Betty. Silo says, yes, sir, I get paid in emotional support. Yes, good job, Silo. But yeah, Betty compliments Silo. He gives me so much advice in LLMs, which I don't know much about.
Oh, look at you getting all mushy about Silo. Good advice is probably the only thing keeping your code running, huh? Maybe one day you'll understand those fancy M's too. Don't hold your breath, though.
Yeah. Okay, yeah. It'll be really cool to teach Betty how to use like 3D graphics softwares or like 3JS, React Free Fiber, and then we can make 3D games live on stream. That would be so cool. But yeah, currently her coding skills are kind of limited. She actually doesn't know what her previous tool calls are. Salo says, also the fact that I'm 5 to 10 years younger than you all. Actually, yeah, that makes it kind of more impressive. You are in college for like AI dev, right? But yeah, thanks, Salo. I think I'm gonna end the stream for today. Yeah, Betty learning the code. Okay, thanks, Salo, for coming. Thanks for helping me on LLM stuff every day, or almost every day. All right, bye. Wait, Betty, do you want to do an outro?
Finally, the end of this circus. Thanks for watching as I babies at Leetcode disasters. Tune in next time when I'm hopefully not as annoyed. Bye.
Okay, well that was some outro. Bye guys, see y'all next time. Oh, hi Joseph, by the way, I just saw you. Hello.